Good afternoon, everybody. Welcome in our webinar from Festo for control cabinet solutions for hazardous environments. We see the number of attendees coming in. We're starting roughly at 4 o'clock local time Dubai. I will give it a few minutes for some people to join, and then we start with our webinar. Yes, good afternoon, everybody. Welcome to our webinar session from Festo regarding control cabinet solutions for hazardous environments. It's a pleasure to welcome you during this session where we are going further into the topic of control cabinet solutions. This topic was initiated on one of the requests from our previous viewers to discuss and go deeper into the topic of pneumatic control cabinets for industrial applications with a specific focus on explosives. We first go with like a small introduction to the session for people who did not participate as before. On the right hand side of your screen, there is an information box where you can ask questions, and also you can place this during the call. We will use this to answer your questions you have on a specific topic, or follow up later on if the topic is a little bit more complex. At the same time, during this webinar, we will be providing you short poll questions to get some feedback about your daily activities and requirements for certain topics, otherwise to understand a little bit about what type of industry segment you are active in. Please feel free, and these will automatically pop up, and you have the opportunity to use this as a multiple choice questions, as well as the option to select multiple answers for the same question. Having said this, it will be a pleasure, and we move ahead with the next topic of this presentation. Industrial automation. As a brief introduction about Festo and our competencies and our activities in the industry, I would like to give you this short overview where we would like to position the activities of Festo in process automation as well as the factory automation. This presentation mainly goes into the process automation, where we are controlling the different types of processes, which can contain gases, liquids, solids, media. And with this comes typically from the field automation, what we consider being the process valves into the field, up to the control part, mainly DCS systems. And with our Festo portfolio and our competences, we are mainly looking the entire scope between the process valves and the DCS system. Besides that, Festo is already for a very long time active in the factory automation as well. So also a lot of our pneumatic competencies, knowledge and technologies we are using for both fields. But for process automation, we always see that the requirements are slightly more specific, higher levels of reliability, more critical factors like ATEX, for example, where the topic for today goes about. So therefore, we see this as a different industry segment. For today's session, we would like to allocate a few focus segments. ATEX and hazardous environments, we see that mainly in a few industry segments, and also the topics and the pictures you see in today's session are mainly related to the chemical industry, mineral processing, oil and gas or petrochemical related, and power and energy. This doesn't mean that these are the only industry segments where we are focusing on. Also, the technologies of today are applicable to other industry segments like water and wastewater technology, for example, or the food and packaging industry, where we also see topics or environments with hazardous situations and the potential of explosive zones. And therefore, we are not neglecting these, but we see the topic of ATEX mainly on these highlighted industry segments from the slide. So first question, also to understand a little bit the background of our audience, I would like to ask, in what type of industry segments are you mainly active? Pop-up question will come up now, and looking forward for your feedback. Also, as a small reminder, if you're active in multiple industry segments, please feel free to click multiple answers. So we're waiting in the meantime until all the polls are closed. Once the last person has finished, we will proceed with the webinar. Let's check. Also, it's a really interesting focus we see between the fine chemical, oil and gas, mineral processing, all around 14 to 15%, and 50% on other industry segments. So again, as a small reminder, please feel free to come up with your questions and to not only consider this presentation on the industry segments mentioned. Okay. Then we move forward. So first of all, we would like to focus for today's topic, the topic of ATEX. ATEX is mainly used in the European market, and also we see therefore a lot of influence from the European market in the Middle East region when it comes to the ATEX directive and the requirements. This doesn't mean that there are other directives available in the market, but also from Festo and as a background, our biggest share is regarding the ATEX directive. For those people who are not really familiar with these directives, is that ATEX is split into two directives, as you can see on the screen, of which one, the first, the ATEX 137, is mainly focused on the health and safety of employees within companies and organizations. This does not really have a direct impact on the ATEX certification of components, which we mainly see in day-to-day requirements. But this directive is very important because it's many cases an input for eventually the equipment which is going to be used and installed at the site. The second directive, the 1895, ATEX 95, is a directive which has a direct application and implement on the products used in potential explosive environments. So these are the directive and the details stating certain requirements for the components and that they are able to be used in a safe way and with the safe manner and instructions. Also, the ATEX directive for both parts is in Europe, these are considered to be a law, and that also means that they need to be implemented, and companies which are being active or handling situations within their facility that can be subject to explosive environments, they need to comply with these two directives. And this is also stated by law, which means that they cannot move around these conditions. Again, ATEX is just one of the few directives available in the world. But for today, our focus will be mainly on the ATEX 95 directive, because this has to do with the components and equipment that we are Festo are able to supply and provide for your installations. So just as an understanding, it's a quick follow-up poll question, but please, we are looking forward to understand what is the standard are you using for your company or organization regarding stating the explosive environments. Please feel free to answer. Again, like the question before, please understand that you can add multiple topics. Okay, majority ATEX, a few people with UL certification. Also we see Ghost and a good share of IEC-AX. Good, I think here we see the answers. So also some people are not directly involved, or maybe not on a really frequent basis, but it seems that we have a good part focused on ATEX. Also the other IEC-AX is a trend which is more and more active since recent years. It's not really a directive. Maybe this is something we will discuss in a different session, but it's mainly a standard, and still in case IEC-AX and ATEX can be joining together in a certain country. So as I mentioned before, ATEX is a law, so not only the IEC-AX will be applicable, but also the ATEX still need to be fulfilled. So in many cases we see a combination of the two. For those people, as a basis within ATEX, we classify potential environments which can be explosive into zones, starting from zone 0 to zone 1 and zone 2. And also in the chart on the right hand side, you can see from zone 1, which is the most likely event that in the event that an explosion can happen, this will be a really high chance with also a very high impact. Zone 1 is the next following one. You also see it very close, and it's building up from the zone 0, where there's an interface or direct link. And also there's a very high potential for having a potential explosion. Within zone 2, this is the most risky environment where an explosion can happen. It doesn't mean that it will be a very high chance, but still there is a possibility that that the explosions can initiate from this area. Depending on the process and the locations of the facility, it's not up to Festo, but it's always something of the customer or the client itself to allocate and to decide which zone is applicable and what type of rules and measures are being implemented. And it's also always for Festo, as we are always asking this as one of the main questions, because we cannot decide what type of zone is what. The other topic I would like to state, although we are having an example of a gasoline station with some tanks and a truck, this can also apply for dust. And also dust, although it's not really directly related to gas, can ensure and create heavy ignitions, and also the results of a dust explosion can be very severe. And the last but not least, and also something we can see here with the example of the car, is that also on a daily basis we are always, and on a frequent basis, we get in contact with zone classifications every time when we fulfill our car with petrol. So we are not always aware about it, but the zone 1 is already a heavy environment when we are filling up our vehicles. So what does this do for us, and what type of impact does it have? So because these processes are controlled by valves, and depending on the requirement, we are having the opportunity to select for certain types of control, and this control is important to come up with a total and a reliable system to comply the specifications. So first of all is the control concept for the pneumatic automation of a process valve. There are two, and one of the common used automation concepts is a so-called decentralized control system, where the process valve with the pneumatic actuator is supplied with air and the control with the pneumatic solenoid valve directly on the actuator, and the electric signals are provided to operate and switch. The part, and also what we've mentioned before, when ATEX is there and there's a potential risk, we always see a big requirement for pneumatic automation because of the fact that it's having a really low power source, and we are not having the high chance for sparks and ignition sources, for example, compared to electric actuation. But the pneumatic solenoid valves are not the only opportunity to control a process valve in the field. As you can see and can imagine, if you're having some more valves, this can be rather complex with a lot of equipment in the field. So the alternative solution, which is more considered as a decentralized control system, is the use of a control panel or a control cabinet, where the pneumatic signals are being provided through tubing, and the cabinet itself is protected against or complies with use in the ATEX environment. But instead of having an individual Namur solenoid valve on each and every actuator, we are using all the solenoid valves combined. And that's also what you can see in the bottom part of the cabinet, where a valve terminal is being used with all the individual solenoid valves well organized and located inside the cabinet. So we were interested, what is the most common automation concept that you are working with? Again, like the questions before, please feel free to provide your answers. And again, multiple answers are possible to provide. Okay, the output, the answers are moving. We see a good spread between both control cabinets and Namur valves, as well as individual Namur solenoids. Really good. So very nice. As of today, we will focus more on the control cabinets, but definitely also for the future, we will go also more into the individual components. So for a decision, and it's not always a certain fact that you need to go for a centralized or a decentralized control system. It really depends on the site conditions and the project requirements. But as some general guidance, rule of thumbs, we provided the pros and the cons against each other, when to go for a decentralized solution with control cabinets or a centralized solution. It depends on impact, for example, the use of field bus communications, the number of I/O cards used in a system, installation time in the field, as well as cable length and the quantity of those, the possibilities for expansion, for example, as well as also the impact on components. So, of course, this presentation will be shared with you, so I will not go over all the topics, but we always try to work as Festo to decide what the best concept is and how to support our customers with the most efficient solution for their project. So we just mentioned before that when we want to control multiple equipments in a zone, this can be zone 1, 2, but we need to have a certain concept for that, and it is an impact on how this decision we are making in our overall costing. Because zone 0 is a really high risky area where we can have a high likelihood of an explosive event, you can imagine that for developing the equipment and the products are need to have a much higher standard to avoid any possible risk for creating an explosive environment. When there are multiple valves installed in a facility, you can imagine that a lot of the equipment needs to be replicated over and over again. So when we look at, for example, at the equipment cost, this can be CAPEX, but also operational cost, for example, for replacements, this can have a longer impact on a plant's facility. So when we have a zone 0, there needs to be a lot of cost in the hardware. And this is not a linear trend, but this is quite exponential. So it makes a really good sense, and you can imagine that a lot of costing can be reduced if equipment can be selected one zone safer as expected or as originally thought of. So that means that, for example, process valve can be located in zone 1, but it doesn't mean that the controls need to be in zone 1. Maybe we can relocate that. So if this is also something where we can make a feasibility study, what the impact would be to design all the equipment for zone 1, for example, or when to design the equipment for a zone slightly safer on zone 2, for example. So the next slide, in the next slide, we will also go a little bit more in detail for that, because I believe we're missing one slide. Okay, anyhow, so as you can imagine, the impact for the costing is very important, and especially when there's a larger number of valves being implemented, we see that control cabinets are providing several benefits compared to individual valves. So the use of valve terminal technology is one of the major benefits compared to individual NAMO solenoid valves, because we can centralize, as you can see in the middle in the blue box, all the solenoid valves which are being connected with the outside of the cabinet to control the individual process valves. And because these valves are the dense application and they are well positioned in the cabinet, we do not need to replicate all the design and all the equipment for the NAMO solenoid valves which are directly mounted on the process actuators. The other part is the relocating equipment to a safer zone. Also in the next slide, I will go a little bit more into detail what type of benefits we can achieve with control cabinets, as well as the function with field communication, which is possible with control cabinets. Here you can see also there's a field bus communication connected to the valve terminals and the I/O inputs of the CPX MPA platform of Festo. Because of the field bus communication, we save a lot of cabling, and also we have the benefits of diagnostics with the main control system. The combination of pneumatics as well as digital inputs, for example, also the intrinsically safe signals, are possible in our valve terminal technology. So also in this picture, you can see that in the blue box, centralized in the cabinet, we have all the pneumatic functions, which is with the bus communication connected with the top part where we can handle all the digital inputs. So there's no need for additional remote I/O equipment or additional cabinets in the field. And one feature for Festo, what we are able to do with the control cabinets for explosive environments, is that we have pre-engineered a lot of multiple designs for the majority of the cases that are possible. So this also brings me to the next part when it comes to engineering a pneumatic control cabinet. Pneumatics have the benefit that they are less likely to create an explosive situation due to the low power consumption and the force of the use of compressed air compared to electric actuation. However, this doesn't mean that we can just use all the pneumatic components in a stainless steel control cabinet and expect that the solution might be safe to handle in explosive environments. Even with the benefits of pneumatics, we need to well engineer and design the control cabinet. That means that even when the individual components are ATEX certified, we still need to ensure that all the calculations and all the designing is done in a correct way to comply with the ambient and the site conditions. Unfortunately, and this is where we see a common mistake, that in the market we see a lot of cases that individual components, ATEX certified or not, are installed in the full design, and then the calculations are being missed and there are no further certification as well as documentation supplied with this equipment. So in that case, people, they believe they have a certain safety within their plant, which actually is not. And as I mentioned in the beginning, because ATEX is a law in a lot of countries where this directive is implemented, this also means that the responsibility of these selections are being placed on the person who did this. Besides control cabinets, this also counts for valve assemblies, where individual items need to be well selected to ensure the compliance with the directive. So one of the topics mentioned before is that we are, with control cabinets, that we are able to relocate pneumatic functions outside the zone. So for example, and this is what we try to illustrate with this picture, in case we have a zone 1 application with a process valve, in this case the butterfly valve, we can control this completely from the zone itself, close by in the most sensitive and hazardous environment. But because we are having the opportunity to decentralize our pneumatic function to a lower zone, instead of zone 1, we move it to zone 2, we can reduce the impact on the control cabinet and the components being selected, which is having a direct cost impact. Also, the same can be done for zone 2, and we can bring the controls to a safer area, where also we can use more standardized components with less costing and less complexity on the certification and the engineering process. This trick can be done. Still, we need to apply some engineering, how to handle certain signals, but it can be very beneficial for the overall costing for when systems are being designed. At the same time, also, it can be sometimes very efficient and easy just to look around in the environment or the location. Sometimes a safe area can already be achieved by an opening in a certain wall, which of course needs to comply according to closing direct requirements, but it can be it doesn't need to be that the distance always gets very long. So in that part, we discussed about the zones. What are the typical ATEX zones that are being used or seen in your projects? Between zone 0 to zone 2, and both apply for gas and dust. Please all again, feel free to apply multiple answers. Let's see, we see a lot of zone 1, zone 2, almost the same. Changing. Okay, really good. Here we see the input, mainly zone 1 and zone 2. Typically zone 1 is a really harsh environment, so we always try to avoid it as much as possible where we can do. But still the majority, it's also our own experience as Festo, that typically the zone 1 and zone 2 are the most common and used ATEX zones that we are supplying our equipment and solutions. So benefits of pneumatic valve terminals, and also in this slide we would like to go a little bit deeper into the valve terminals we just mentioned before. And one of our solutions can be achieved with our CPX platform, where we have the function to provide intrinsically safe sections for the I/O signals. Mainly when using a valve terminal, we are having the pneumatic outputs which are seen, and we are using tubing to go into to connect the valve terminal with the process valve in the field. But also many cases there is a limit switch box which provides the open or close feedback signal which needs to be communicated to the DCS system. Well, so limit switch boxes are there in two styles, and one of the types we see are the EXD. So the ATEX protection is achieved by a housing, which is a very sturdy design, which is capable to protect the environment from any type of sparks or ignitions happening inside the sensor box. That means also the control signals can vary between 24 or 240 volt AC. And these signals can be connected to the valve terminal, which can communicate these parts from a field bus level to the main DCS system. Important to see, and also our equipment, typically EXD sensor boxes are used in zone 1 or zone 0, and of course zone 21 or 20 for dust applications. With our Festo valve terminals, we are capable to being applied these equipment in zone 2 or 22 for dust, and already made a step forward to get closer to a safe situation. But besides the limit switch boxes, which are EXD type, so we have the second part, which also is commonly used, which is a so-called intrinsically safe design, EXIA. And within these sensor boxes, we are using a very low voltage, for 8.4 volt DC, which also can be considered as a NAMUR signal. And the benefit for this signal is that the voltage is, and the power of the voltage is so low that when the two wires of the signal are being connected together, and a spark will happen, that this spark will not have the power and the force to further initiate an possible explosion. This type of signal is specifically being used, and also you need to apply a lot of equipment which is needed to achieve a certain signal. And with Festo's CPXP platform, we have built in our digital input modules this barrier, and because of this integrated barrier where we can handle up to 8 digital inputs per module, as you can see, we are able to avoid the isolators or the barriers which are normally used to make the difference and the split between the non-intrinsically safe and the intrinsically safe parts within the zones. And this is a direct cost saving when multiple digital inputs are being considered. The next part where we also see benefits are the pre-engineered ATEX cabinets. As I mentioned before, is that when building or designing a pneumatic control cabinet for ATEX zones, all the components on the inside need to be engineered and selected to comply with the requirements for and the ambient conditions for the zone where this cabinet is being installed. Also, to avoid a lot of time in engineering and quoting and our response to the market, we developed a controls panel and a control cabinet with certain features already integrated. So what we've standardized, the most common design, and based on the requirements for the digital inputs as well as the outputs in terms of the pneumatic solenoid valves, we made all the pre-configurations that can be directly installed in the control box as it is. So as you can see here, we have this control cabinet with certain slots which are still empty, and depending on the requirements for the number of digital inputs and the outputs, we only need to select the control valve terminal with the inputs and the pneumatic solenoid valves and mount them directly in the cabinet, and then our cabinets are ready to be quoted, as well as we can save a lot of time in the manufacturing of them. So the benefits on a row, and also here on the right hand side you can see a little bit more details about the digital inputs as well as the pneumatic part for the control cabinet. But as you can see from the picture before, all the layout and all the main components which are not need to be configured, are not configurable or need to be configured for the job, are all kept at the same. So in total, this brings us up to 14 pre-configured design and configurations we've made. We vary between the 8 to 32 solenoids and with up to 64 digital inputs, and these can also be intrinsically safe. Also, we have the benefit of using hot swap function, and that means that we can interchange a pneumatic solenoid while the rest of the valve terminal is still being pressurized and can still be in operation. So this saves and reduces the downtime when maintenance or repairs need to be made on the solenoid. As I mentioned, capable to include standards, 24 volt signals, but also the NAMUR intrinsically safe EXIA. And the benefit is we are working with one design for all configurable options, which saves a lot of effort. And also we standardized and we put all our engineering time in pre-selected models, we are able to have a rough cost reduction in efforts of plus minus 20% compared to the design of each and every cabinet one by one. And at the end, this also will improve our delivery time because we have a better understanding about the possible requirements, which improves our response time to the market. So it's not always possible that we can provide a pre-designed control cabinet, and also certain conditions require for other equipment, other designs. So besides this, also we have the opportunity as Festo to work more with you on customized solutions where we are able to integrate and design specifically for your needs, and we can have this on a very low level where we are only looking into individual components like the solenoids with the protective cover, up to more complex control cabinets with sometimes higher zone classifications, specific equipment to comply with other hardware at the facility. And this is also something, it's a little bit longer process, but it provides also a lot of benefit and value. The main reason for this is, and it's something we mentioned before for ATEX, where we are working with certification, is the fact that all the items inside the cabinet are designed. And once the design is being frozen, no changes are able to be made without following all the details of the directive. So this is also one note, and the common practice we see sometimes when cabinets do not really fulfill the site conditions, people believe that they can make a small modification by themselves in the field. For normal control cabinets, because of the modular buildup of our components, this is not really a problem. But for ATEX, and this is a big topic, because when there are changes being made in the design, it also means that the calculations and the selections made during the engineering process are no longer valid. That means that the certificate cannot be fulfilled. So that means that once the change is being made, the certification on the full control cabinet as provided, even if it's a small topic, are not valid any longer. So besides the equipment, we have some additional support by Festo. As mentioned, engineering is one. So this is also where we're not only looking into the individual components for an application, but also we look, for example, for air requirements between, for example, small valve and actuators and bigger ones. Also, things like tube length are possible to have an impact on the reliability of your system, and these are services we are supporting with. The other part is the documentation. You can think about it, for example, about drawings in E-plan, CAD drawings during the submittal stage, which helps you to lay out your site conditions better, but also the certifications which Festo provides on the cabinets. So this means that everything within the control cabinet are certified and bear the quality stamp of Festo, which helps you with the overall validation of the compliance stated by the ATEX directive. For those projects located, we have, as Festo, we have FAT testing, factory acceptance test. So before the cabinets are being shipped to a site location, we have the possibility to test all the functions and get you or your engineers familiar with the to-be shipped equipment and be ensured that everything fulfills site conditions. But also sometimes support on site is required, where our field engineers for the Middle East, English and Arabic speaking are coming to your site, and we support you with the implementation of the goods and the equipment provided, and also avoid you that we have any type of startup issues or troubleshooting at the beginning, and we can be physically there. How these days, of course, with COVID, we are finding new ways as well, like video conferencing, but the tools and the service and supports are available. And at the end, because when there are control cabinets to control pneumatic components, we have the one-stop shop services available, where we not only provide the control cabinets, but also the field automations like the butterfly valves, ball valves and equipment in between, as well as tubing. So this reduces for you the number of suppliers and the additional benefit to fulfill all the needs and have a better and more controlled supply chain. So what type of services are beneficial for you? Are you, for example, looking more into the design and engineering support of Festo? Can we help you more with, for example, documentation? So instead of your engineering team are doing a lot of engineering, we help you with our support, FAT testing, commissioning at site. We are looking forward for your feedback, how we can further optimize ourselves to help you better in the future. Can we start the poll, please? The poll is open, or I don't see the poll being opened. I think we have a small. I'm sure it's there, still there. Okay, I see that we just lost the poll. My colleague who's supposed to start the poll he's not here. Okay, here the poll just opened. Thank you. Sorry for the delay. So again, please let us know how we can help you better. And of course, multiple questions or answers are possible. Poll is in progress. Getting the contacts. I see a lot of people. The majority of the group require all the support of Festo, and of course, which is a pleasure for us to do. So also, this is the mix in between. Is not only to look into one component, but we see that especially the benefits and the savings can be achieved by combining multiple technologies and have the overlap between the different parts. Okay, then I think we can move to the next part. So this also brings us to the end, and we also would like to inform you about our next webinar. Today we discussed in detail the possibilities for ATEX control cabinets in the different zone 1 and 2 for both gas and dust. What is the scope of Festo and what can we offer for these applications and site conditions? But also we are looking into the field automation. And our next webinar, which will be provided by my colleague, Mr. Nizar Niran, will be going more into detail about the pneumatic actuators, the ATEX solenoid valves of Festo when they are required, and the sensor boxes with filter regulators. And we already want to use you and invite you for the next webinar to join us. And we will go further in detail on these topics to completely give you the full automation triangle in more detail. So please put it in your agenda. Also, you will be getting an invitation for this next session. And also, we would like to thank you for your participation. And if you have any types of questions, you can contact us through the details on the screen. Please do not forget to follow us also on LinkedIn, because we will be frequently updating you with our updates, our developments, and new technologies. At the end of this session, also I would like to use this to inform you that there will be a small survey with a few questions where we ask your support to give the feedback about having a better understanding about how we can further optimize our webinars, or if you have certain topics which we need to discuss in more detail, like we today did with the ATEX control cabinets. And then we are looking forward to see you in the next session. So we would thank you very much for your participation and commitment. And we are looking very much to the next time. Wish you all good business and stay safe in these days, and see you next time. Bye-bye.